So welcome back all of you to the next video of this series. So in this video what we will do is we will create our first MCP tool project, and in order to do so we will use the GitHub MCP server tool itself. I'll just show you the final output that we will achieve at the end of this particular video. This is the final interface, and I'm basically passing the GitHub repo URL. So once I loaded the repo, for example, if I want to understand, explain readme file of this repo, this user input it passed to AI, the AI connected with the MCP server, the MCP server called the MCP tool, and the MCP tool will be used to fetch the answer. As you can see, the this particular readme file for this GitHub MCP server is basically what is it, key use cases, deployment options, installation, configuration. So using the MCP tool, you can have this README file. You can access any public repository. You can create repository. You can modify codes. You can push the codes directly from here itself into into your personal projects. Okay. So this is what we will end up creating at the end of this particular video. Now, now coming back, what is an MCP? Okay. So I will not actually create an MCP here in this particular video. What I will do is I will teach you how to use an MCP. And in order to understand the MCP, we will start with an example. So just let's start with an example. Suppose you went to a restaurant to place an order. Okay. Once you went to the restaurant, there would be a waiter for collecting the order. You place your order to the waiter. The waiter goes to the kitchen. The different chefs which are supposed to prepare your order. Once the order is prepared, okay, the chefs hand over the food to the waiter. The waiter comes and hand over the food to you. Now, in this entire example, the waiter is an MCP. Instead of you communicating with the chefs, it is you who are supposed to communicate with the waiter, and the waiter will do the all the necessary communication with the chefs. When the food is prepared, the chefs will hand over the food to waiter, and the waiter will hand over the food to you. Okay. So in this entire example, the waiter is an MCP. Okay. Now the question is why there is a need for an MCP. Suppose suppose you went to a restaurant. The restaurant says you are supposed to scan a QR code and then place an order. Okay. It could also be possible that you are supposed to place an order using the hard code menu. It could also be possible that you are supposed to do a self service, in the sense directly go to the chefs or the kitchens, place your order and collect your order. Now from the user's perspective, there are different ways in which the order could be placed, and everyone has to learn that way. Now come to the tech part, in the sense right now we are using Git server. Obviously we want to connect with the different server, which is Figma server for the design part. What if we also want to connect the Notion server? Now instead of learning three different ways to connect with three different servers, what if I say that there is only one thing, in the sense connect through an MCP. Now once you connect through the MCP, irrespective of the server on the other side, every connection could be made using only one tool, which is an MCP, and that is the benefit of using an MCP. Now, similar to the analogy for the MCP, the next question could be something like this. What if the chefs and the waiter communicate in different languages? As you can see, we have three different chefs communicating in three different languages, and we have waiter which is communicating in different languages. Obviously, in order to have this communication between waiter and the chefs, we need a translator. In the similar MCP part, we have MCP adapter. In a sense, we don't need to have learned different tech stacks in order to connect with Git server, Figma server, and the Notion servers. The MCP will take care of it in order to connect with the different servers using the MCP adapter. So these are the two important concepts, in the sense what is an MCP? MCP is basically an analogous to the waiter. The waiter is someone who connects with the different servers and gets the output done from the server and hands over to you. Okay. Why there is a need for MCP? It's because instead of learning three different ways to connect with three different servers, I will connect with an MCP, the AI will connect with an MCP, and the MCP will take care of the next part. What is an MCP adapter? It's basically, instead of communicating in three different languages with the waiter, the MCP adapter is basically like a translator, in the sense it can connect with an MCP with the servers written in any sort of code language. Okay. So MCP part is done, MCP adapter is done. Now the Second thing which is important from this particular video perspective is LangChain and LangGraph. Again, I will start with an example. Assume now coming to the LangChain and LangGraph, what I'll do is again I'll start with some analogy. So I will compare the LangChain from the human and the agent perspective. Suppose from the human perspective, okay, in order to think we have brains. For the agents, in order to think they have LLM. The LLMs could be ChatGPT, Groq, Claude, anything that you want to say. For humans, we have sensory organs in the limbs. In a sense, in order to see, we have eye tool. In order to smell, we have nose tool. Obviously, once we are defining agents, we will also have different tools. It could be anything, say revenue tool, inventory tool, search tool. In our video, we have seen that we can actually do readme files. So it's basically read content or create repository or list down files and everything. So for everything, we will have a tool. From the human's perspective, this brain and this tool is connected using a nervous system. Similarly, for the agents also, this LLM, which is ChatGPT, Grok, or Claude, anything, is connected to the tool using LangChain. Okay, so LangChain is just similar to a nervous system in the sense it helps us to connect from the LLM with the tools, and obviously it also stores some sort of informations. Okay, now coming to the LangGraph. Now before starting the LangGraph, just I'll iterate the routine of the human beings. So for example, when we wake up in the morning, we decides whether we want to have some sort of exercise, or we want to go for a washroom, or we want to go for a walk. Once we come from say walk, have our washrooms, we could feel that we are hungry as of now. Again, we will decide depending upon the time that we have in order to cook food or to order food. Once we have food, okay, once we have food, we want to go to the office. It could be possible that we may decide whether we want to go with the public transport or private transport. Once we arrive at the office, again there will be multiple decision points. And finally, at the end of the office, we went to a home. Again, we can have different decisions whether we want to cook food or we want to order food, or if we want to read some sort of book, or if we want to pursue any sort of hobby. And at the end, we will go and sleep. So this is the entire life cycle for the human beings. Okay, in the sense, we as a human has some start point. Okay, we have some end point. Okay, and between this start point and end point, we are supposed to take multiple decisions, and based on each decisions, our nodes do changes. Okay, similarly for the agents also, we will define a start point. Okay, what will the starting point say? Whenever we talked about this particular thing, explain readme file of this repo, which was an user input. Obviously the user input will be a start point. Once we have the start point, we will pass the same thing to LLM. Okay, once the LLM interprets this particular thing, it can call multiple tools, which again is a decision making body. The tool will give an output, the LLM will review it. The LLM might call different tool, the different tool might give a different output, and this process will go and go and go on. Ultimately, the LLM will decide, okay, this is the final output that we want to have, and finally will come to an end state. So LangChain is basically a sort of nervous system in the sense connecting between the agents and the tools. LangGraph basically will help you to understand the start point, the end point, and the different decision nodes which the agent is supposed to take. Okay, so this is what we will do in this particular video. In the sense, we will define our MCP tool. In the sense, we will connect with the MCP server, and once we have connected with the MCP server, which is a GitHub server, we will have MCP tools or the GitHub tools. We define LangChain and LangGraph, and I'll show you how to use it. Finally, this is a final graph that we will use it. Okay, and this is what I define in all my videos. At the beginning of this video, we will have this graph, and we will create files for each of these steps, and finally at the end of this particular video, we will connect all these files using the LangGraph. So as you can see, this is a GitHub server. The GitHub server has different tools. So what we will do is we will define our LLM first, and then we will connect with the GitHub server. Once we connect the GitHub server, obviously the server will come with a tool, and that is why we will attach all our tools with the LLM. Once we attach tools with LLM, it will become an agent. We will pass on the prompt to the agent, as in how to operate this particular MCP tool. It's sort of the instruction which has to be provided to the LLM. So the LLM will have tools, the LLM will have the prompt. Once the user will pass the input, the LLM will read the user input, will try to fetch the correct tool based on the prompt that we will decide. and finally it will give an output. And this entire thing, this entire decision making body, in the sense start point, then decision making, and then the end point, in the sense passing instruction from the LLM back to the user, will be recorded in a LangGraph, and we will show you at the end of this particular video. Now what I'll do is, since would be using the GitHub, I would be using the VS Code and the Python. So make sure that the VS Code is already installed in a laptop and along with Python. If it is not done, what I'll do is open my channel. Okay, go to my playlist, go in this into this particular playlist which is talk with your bills, and if you open it in the second video of this series, which is setting up the lab, install Python, VS Code, and Olama is basically a free LLM. Okay, so do this necessary installation before proceeding ahead. So once you have done the installation for the VS Code, and if you open it, this is how it will look like. Simply go on file, open folder. Okay, if you want to create a folder, just create a folder. I've already created a folder which is a GitHub MCP tool, and we'll do everything here right now. Okay, create your first file, which is by clicking here. Simply I'm saying MCP client.py. Okay, now if you go and search for the GitHub MCP server, something like this. Okay, if you open it up, it will give you all the important instructions, the codes and everything. And obviously, in order to connect either with the VS Code, or if you want to use in cloud or anywhere else, you will have all sort of configuration which you are supposed to use. Since we are using the VS Code, we will stick to this particular thing, in the sense either we can use this part or this part. Now, if you remember, see, whenever you want to enter into a GitHub MCP tool, in order to use the MCP tool, you need to have an access to the server. One thing that you need to understand is, if you log in into any system, you are supposed to provide username and password. And once you provide the username and password and the authentication is successful, then only you are supposed to enter on the other side of the server. The same thing here also, we can hard code username and password again, but that is not the best way to do it. What we will do is we will generate a token. Okay, and every time when you are connecting with the GitHub server for the MCP tools, the access will check for the token, and if the token is authenticated, it will give you a free access to all the GitHub MCP tools. So the first thing is to generate a token. In order to do so, first of all, you need to create your account on GitHub. If you haven't done so, please create your account. Go into the settings for the GitHub. Okay, once you open the settings, this is how the page would look like. Simply on the left hand side, go for the credentials. In the credentials, you can see all these three things. You can have the access through this particular thing, which is fine grained personal access token, or the PAT, or you can go for the authorized authorization. In our video, we will use the personal access token for the authorization part. Simply click here and generate new token. Once you click on generate new token, it will ask you to verify your email address using the OTP. Once the verification is complete, a token would be generated. I have already created the token for myself. Okay, what I want to show here is, once you generate the token, okay, there is something which is called as the permissions, which would ask from you. Okay, if you see in my permissions, I have given the access to all the repository which are public on GitHub. Apart from that, I can also have additional access for my own repository, in the sense I can have read and write access that I've added. Content wise, I can read any content. I can verify issues as far as read only is concerned. Pull request, again read only. You can add permission as per your requirement. There is no stopping into that. However, for the bare minimum, please ensure these particular things are updated for you. Okay, now I'm assuming you have a generated token. Okay, this if I show you how the token would look like, this is something the token would look like. Okay, if you see here, this is a token for me. Obviously, in order to establish the authorization, we need to pass the token. So simply go into your VS Code. Again, click here, create a new file which is .env file. See, env file basically is used to put all your important credentials at one place, and that is a standard way to write the codes. Because once you are moving the codes from, say, your personal laptop to your GitHub account, obviously you don't want to send the credentials, and that is why you are supposed to add one more file, which is git ignore. As of now, I'm living into it. I'm putting all my credentials or the important parameters in one file, which is .env file, and simply putting it here. So my GitHub personal access token is something here. Okay. Now moving back, this is what we are talking about. If you see, this is a code we are supposed to use. So simply I have already written the codes. I will simply copy it and paste it here, and I'll explain it what exactly this code means. Okay. See, I'm not generating any new thing. I'm simply copying it from the server and pasting here. See, what I'm doing here right now is I'm importing OS, which is operating system. I'll tell you why. Importing async function. I'll tell you why. From .env, I am loading the .env file. If you remember, in the .env file, we have our personal token, which we would be using for the access part. So I'm importing the .env file here. Okay. Multi-server MCP client. This is basically the adapter that we have discussed. Okay. Now we are defining our first function, which is a get MCP client. Putting it here as an adapter. In this, we will pass our personal access token. If you see, I'm saying operating system, go to .env file. Within the .env file, get me the GitHub personal access token and store it into GitHub path. Okay. If I don't have personal access token, this is the error that I want to see. But if I have the personal access token, proceed here, in the sense this is the adapter, and this is a part that I have shown you in the GitHub server. Okay. So tomorrow, apart from GitHub server, you also want to add Figma as your MCP client. So simply, if you see here, this part is done. Put enter. I don't know how to use Figma MCP server as of now, but something it will look like the same thing here, in the sense double quotes, blah 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 blah, and all these things. If you want to add some different server, the same thing you can do, and this is how you can connect the multiple servers on the same client. And this is what the adapter was supposed to do, in the sense the waiter can communicate with n number of chefs speaking in n number of languages. So this is an adapter which is talking to GitHub also, which is talking to Figma also, which is talking to Notion also, maybe it is talking to Obsidian also. Okay, so these all things can be done here. As of now in our video, since we are sticking our discussion to only GitHub MCP server, so this is the only one server that I'm putting it now, but you can connect as many servers as you want. Obviously, every server will have personal access token. You can add your personal access token. Say for example, Figma personal access token, this thing, Notion personal access token, this thing. Pass everything here, and one by one, if you see, we are passing the authorizations. Now every time I will put a request to the GitHub, my personal access token will go to the GitHub. It will check if the personal access token is a valid credentials. If yes, it will give me an access. If that is not a valid credentials, it will reject the access. Okay. So this particular part, which is a connection with the MCP client, has been done. Now if you remember, if you go into this particular thing, okay, once you connect to the GitHub server, the tool by default will come with the GitHub server. So we are what we will do is we will basically import the tools, since the connection with the GitHub server is complete. So we will write a different function. The function is basically get MCP tool, and if you remember, I'm putting it as a async function. Now what you need to understand here is, see, this is a synchronous function, in the sense whenever the file is uploaded, the very first function that we will run is this particular thing. Okay. Now assume we have one server which is GitHub, we have different servers as Figma, we have different server as a Notion. Now as soon as this is done, obviously I need to connect with a GitHub tool from the GitHub server. I need to connect with the Figma tool from the Figma server. Obviously this tool connection can be asynchronous, in the sense it doesn't matter if I'm not able to connect with the GitHub tool. If I'm able to connect with the Figma tool, it doesn't stops me from using it. So basically I'm putting everything here, which is a get MCP tool as async function, in the sense there is no restriction for me that the first has to be the GitHub tool, the second has to be Figma tool. The first can be Figma tool, the second can be the GitHub tool also. Okay. So what I'm doing here right now is whatever here we have is under this function, which is get MCP client. Okay. So I'm passing this get MCP client as a client. This client will have tools. I'm passing everything as all tools. So this function is done. Now obviously I want to show you what are the different tools on the GitHub. Okay, so I'm basically printing the name of all the tools. For each tool I'm printing the name and description. Okay. Now one thing that is important here, the size of the tools, the GitHub tools is very high, and since we are using a free LLM, there could be actually a problem with the tokens. So I am restricting the tools to only one tool, which I have listed here. If you see that of all the tools that we have here, of all the tools we have here, finally we will use only one tool, and which is get file content. Obviously if you want to use all the tools, simply remove this get file content. Okay, this particular filtered part. Okay, remove this particular thing, simply return all tools, and all the tools would be loaded into your file. So finally we will run this particular thing. Okay, I'm just commenting it out. Just save it. Terminal, new terminal. Simply write python mcp client.py. Save everything. Okay. What we have here is, this was our command. As you can see, there are total 44 tools in the GitHub MCP server. Okay. For each tool, this is a tool name and this is a description. Okay. Add comment to pending review. What does it mean? Basically this particular thing. Create branch. What does it mean? This is a particular thing. Okay. If you see here, we had put that as of now we will use only one tool, which is get file content. Okay. And this is a get file content. Finally, of all the tools with the descriptions, if we reach at the end, okay, you can see tools actually loaded, which is a get file content. As of now, because of some token issue, I'm restricting it to get file content. Obviously if you're creating a personal project, there is no restriction, and obviously the model that we'll use won't be a free model, in the sense some sort of premium version, and there won't be any issue with the token part. So in this entire series of this video, we will stick our discussion to only one tool, just for a personal project perspective. But obviously if you want to use all the tools, simply in the code part make a small changes, in the sense remove this filtered part and return all tools. All the tools would be loaded from your side. So this particular thing, in the sense GitHub server to tools, this part is done. Now what we will do is we will talk about this particular LLM part. Okay, any LLM you can use. You can use ChatGPT, Groq, or Claude, Sonnet, anything that you want to use. In our discussion we will use Groq, in the sense it is very easy to use and the token free tokens is very high. Okay, so simply log in as Groq API keys. Once you log in it, there is an option to create an API key. Okay, simply put the name whatever you want, no expiry, which is all good. Okay, submit and a key would be generated. Okay, I've already generated the key and I will show you. This is how it looks like. Okay, grow API key, something like this. So I will be using the same API key, in the sense if I go in the .env file. Okay, and I'll place my Groq API key here. Okay, save it. Now we will create one more file, which is Groq client.py, which is basically llm.py, anything that you want. Going back again, I won't be writing codes. I will be simply showing you what I am doing right now. See, again importing OS, which is operating system, and now you understand that since my personal API key is here, and I want to use it into this Groq client py. So this OS will help me to import my API key from .env file to Groq client file. Okay, that's it. This is again is a library within LangChain. Okay, we are defining a function which is get LLM. We are passing a model within the Groq, which is this one. You can pass different model as you want. There is no restriction. The temperature we are putting at as 0.1. Again, temperature could vary from 0 to 2. Temperature is basically a lever to control the creativity of the model. If the temperature is 0, it means you are asking the model to stick to the facts. If the temperature is 2, you are giving the permission the model to be as creative as possible. Since in our discussion we want our model to stick to the facts, that is why I'm putting temperature as 0. 0.1. Even I can put 0. 0.0, also 0. 0.2. Okay, in this particular function I'm passing the API key. Okay, from where I'm getting an API key, call the operating system, go to .env file. Within that env file, get the API key. Okay, if I don't have an API key, simply give me an error, which is important from debugging perspective. If I have the API key, basically return chat Groq. Okay, model would be model, you can choose any different model as you want. Temperature would be temperature, which is 0. 0.1, and the API key would be an API key. Okay, so for example, if I want to see this particular thing, similarly in the MCP client, when we run, we have this particular output. Okay, for example, in the Groq client also we want to see an output. Simply make a small changes, in the sense LLM equal to this particular thing. Okay, print model loaded model. Okay, now if you want to run it, simply put if name is equal to get LLM, simply save it and run it. This is a output, in the sense print model loaded, which is here the same thing, model loaded. Okay, and this was our model name. Okay, that's it. So we would be removing this particular thing, in a sense, just for the sanity check, in a sense model is working properly. Okay, done. So thing, in a sense, we defined the GitHub server, we connected with the tool, we defined LLM. Okay, now what we will do is we will basically define the prompt part and a simple a state.py file. Okay, so let's create our prompt file. Just go there, click here, write prompt.py. Okay, now see, prompt is basically an instruction file which has to be sent to the LLM. And since we are using LangChain LangGraph, so I'll show you. If you go and type LangChain system message, okay, this is something which will come up. You can basically go through the document part. For the code part, what I wanted to show you is, within LangChain there is an inbuilt tool or a library, you can say, which is system message. Okay, and in the system message we can pass our instructions. So we would be using the same thing. Instead of defining everything from scratch, just import everything from langchain dot core import system message. Okay, sorry. Okay, now I am saying basically the prompt name is system message. You can type prompt also, anything that you want. This is the library content. So basically you can pass on any instructions that you want to pass on. So for example, you are a GitHub assistant. Okay, in order to prevent hallucination also you can pass instructions. So for example, only use one tool at a time, and yeah, you can add as many instructions as you want here, and our prompt file is ready. If you go, what I wanted to show you here is, in our case, basically in this MCP tool, since the prompt is not going to be very heavy, it's really basically a two-line code. But for example, if you are going to create an agent for something which is different from the GitHub, where the prompt is of utmost important in the sense how the agent should behave, obviously your prompt file will go up. But the best part is all the instruction has to be written in plain English. Okay, it's just two lines of codes here, and everything would be a part of content which would be a plain English, so it is not a very difficult task to write the prompt. Okay, now moving back, we said that we will now define state.py file. Okay, now before defining our state.py file, I just wanted to show you that this was something which we said at the beginning of the video that we will end up creating it. Okay, now on the left hand side, if you go, there is state log, and if I click on expand logs, I can basically see the entire flow of my agent. Okay, this was the first question as a human that I asked, that explain the readme file for this particular repo. It went to the LLM, which is an AI message. We did a tool call. The name of the tool is get file contents. The tool passed on some sort of message here, and finally the AI give the final output to us in this particular thing. So this state log is basically a logbook, you can say, or is a history book, which actually will give you all the steps which is performed by the agent right from start to end, and also the decisions taken. So for example, instead of writing explain readme file in this repo, I could have written that create a repo file for me. So instead of calling get file content, it would have called a MCP tool, which is create repository, and would have done something that is a creation of the tool. Also, if there is multiple tools, decisions will be taken. If you remember, we talked from the human analogy, in the sense when you wake up in the morning, you have three things to do. After say coming from walk, you decided that you are hungry, you will order food or you will make food. Again, it is decision point of time. You went to the office, you take a decision whether you want to commute using public transport and private transport. So every steps, every decision is recorded somewhere, and this is called as a state log or the state file that we will use to create it. And right now you should be able to connect that it is very important file, in the sense it gives you a visibility that how my agent has been behaving, and if anything goes wrong, I can actually go and see where my agent has not been doing good. Okay, so we will basically create a state file for this particular thing. One thing you can notice here is this state file is basically a type of dictionary where we have a key value pair, in the sense this is a key, this is a value, this is a key, this is a value, this is a key, this is a value. One thing that we can do is we can go and create a dictionary in a traditional way. Since we are using LangChain, I don't want to create or invent something from very scratch. We will directly again borrow one library within the LangChain which has this state log function, and we will use it to define our entire logbook or the history book. Okay, so just go again here. Okay, create a new file which is state.py. Okay, I am not going to write the codes. I'll just directly show you the code and will explain it. Again, if you go and search, okay, state type dictionary, it you will get on the Google what does it means. So basically from LangGraph, I am importing add messages. From typing, I am importing these three things. I'll show you why. So I'm basically defining a class which is a type of a dictionary. A dictionary in the sense it will have a key value pair. This is a plain instruction that will go to the LLM, in the sense whenever the LLM will go through this particular function, it will go through this particular thing which is docstring part, will try to understand what this function is supposed to do. Okay, even though if you are removing this particular thing, it is not going to impact your entire agent part. Okay, now what I'm saying here is, for every message, okay, what is message? If you go back, if I expand my log, this entire thing is a message. What I'm saying here is, whenever there is an instructions, or whenever there is a function that is performed, a message would be generated. What you should do is you should update my message with add message, whatever the message has been generated in the form of the list. Okay, so this is the entire list. Okay, every time a new message is generated, just add my message into my list, which is a state file. Okay, that's it. and I'm also passing out the name of the repo. It could be possible, say you are working with multiple repos, so every time whenever message generated, I'm able to see what was the repo name. Okay, here it is just a safety factor. Even if you exclude this repo name, it is not going to impact your agent. Okay, thus moving back, we defined the prompt, we defined the state file. Okay, we have already defined LLM, we have already defined GitHub server and MCP tool. Now what we will do is we will basically do a connection between this entire thing, in the sense user input to LLM with prompt, LLM with my this MCP tool, and finally we will have an output. So let's create our final file, which is main.py, I'll say, and we will put our entire connection part here. See, I've already prepared my main.py file. Okay, and I'll explain one by one what exactly I've written. They are some of the libraries that we will use directly, and this particular things, in the sense from .env, importing this particular thing, from this particular file I'm importing my LLM. All these things have already been discussed in just a few minutes ago. See, as of now we are using the free version of Groq, and we are directly calling MCP tool for the GitHub. The problem which I encountered in this particular thing was the tool message which was giving an output based on the user input was sometimes exceeding the maximum free token which was allowed under Groq. So as a safety feature, and just to ensure that my project runs, okay, what I'm doing here right now is I'm basically limiting my input which will feed to the LLM, which is Groq here, to 6000. In the sense, whenever I will have the tool message where the content is greater than 6000, I will basically trunk it down and will share the first 6000 characters only to my LLM. Okay, so what I'm doing first of all is I'm defining a function which is truncate if tool message. The input would be a message. Okay, now if you go and open the state log, okay, this particular thing, see, state log is our only source of truth, and from now ahead whatever the function that we will write it, we will directly use this particular thing in our all the functions. Now if you see here, I'm saying that whenever the tool message, this is a tool message which is a key, and this is a value, in the sense this particular part is message, this particular entire message will go to AI is basically LLM or the Groq that we are using here right now. So what I'm saying is whenever I will have a tool message, I will basically check for the length of the content which is generated by the tool message. If that length of the content is less than 6000, then it's well and good, we will directly pass it to LLM. If the length or the content is greater than 6000, I will basically trunk it down and then we will pass to the AI message. I am not checking the length of the content for the human message. Obviously it could be even possible that as a human we are also passing the message length which is greater than 6000 characters or 6000 tokens. But for the simplicity's sake, in this video, we will just check the length of the tool message and then we will take a decision. So this is our first function. Okay. What I'm saying is in the message, in the sense, if the message is not a tool message, if you go again back, this particular thing, if it's not a tool message, obviously I don't need to worry about return message. If it's a tool message, basically convert the tool message into a string. Okay, count the length of this content. If the length of the content is less than maximum tool message characters, which is 6000, well and good, move ahead. If it is greater than 6000, basically you are supposed to truncate down to the maximum tool message characters, which is 6000. Okay, once we have truncate down, return the tool message. In the sense, initially it could be possible the tool message is 8000 characters. After trunking down, it becomes 6000 characters. So I'm basically taking that 6000 characters as a return message, as a tool message. Okay, so this is a function which is basically helping us to trim us down the tool message so that I can use a free version of my Groq or the LLM. If you also want to check or truncate down the human message, okay, so what you can do is instead of writing this particular thing, you can bypass this. You can simply say, or you can comment it out, you can simply say whatever the message I have, I will convert each of the message into string first, and then I will compare it against my maximum tool characters. And if that characteristic is less than 6000, obviously I will return it. If it is greater than 6000, I will simply trunk it down and then we'll return the output. Okay. Now coming back to our graph part, in this particular thing, we said that whenever the user input we will pass it to the LLM. Okay. Obviously, if I go about a little high level of architecture for this particular conversation that we will have, this is something that we will now use it from now on. In the sense, we will have the user input. Okay, we will basically call a graph. I will explain you what does it means in the sense this particular thing. If the graph is already built here, obviously there is no point in recreating it. We will simply attach the human message in the graph. We will pass it to the assistant node. The assistant node will pass it to the LLM, which is a Groq. The Groq will decide whether tool has to be called or not. If a tool has to be called, it will call the GitHub MCP tool. The tool will generate an output. The output will go to the assistant. The assistant will again feed the output from the tool to the LLM. LLM again will take a call if a tool has to be called or not. If no tool has to be called, it will finally pass the final message as an output. Okay. So this is a little high version or the actual architecture that we will discuss right now from now on. Okay. So what we will do here as of now, we will talk about this particular thing. Okay. In the sense, creating an assistant node obviously will have input coming from both either user input or from the output which is generated by the MCP tool. Whatever the case it may be, finally the assistant node will pass this input which is had received either from the user input or from the tool to the LLM. Okay. So what we will do here is we will define our second function, which is building the graph. So what I'm doing here right now is graph is basically this particular thing. Don't get confused by the graph part in the sense the state log that we have already created. Na? This particular thing is called as a graph. So we will keep on creating this particular graph in the sense we will define our assistant node, our LLM, our tool call, the conditions for the yes and no, and finally we'll deliver the output. Okay. So moving back, I'm basically defining a function which is underscore build underscore graph. Okay. I'm getting all my MCP tools. We have already defined our MCP tools. If you remember, this was the particular thing from the MCP client file. We are importing our MCP tools. Okay. We are importing our MCP tools. Okay. We already have our LLM. Okay. Now what I will do is I will do this particular thing. If you remember, we have our LLM, we have the tool. We need to connect our tool with the LLM. Okay. And once we connect our tool with the LLM, it will become an agent. That is the first connection. So simply going ahead, what I'm saying is I'm getting my LLM and I am binding my tool, okay, which is tools, which is bind underscore tools, and I'm passing tools, which is here. Now my LLM and my tools are connected and I have created my first agent. So the first connection we have done. Okay. Now we will define our assistant. We have done this particular thing in the sense Groq with LLM. We have connected this particular thing. Okay. Now what we will do is we will define our assistant here. How to define assistant? Again, what I told you, there are two ways in which the assistant will receive an input, one from the MCP tool, one from the human message. The human message, I'm saying that we are assuming the characteristic length will be less than 6000. So no point in doing this check or the truncating part. However, if there is a tool message, we will truncate down to 6000 characters if it exceeds 6000 characters. Okay. So going ahead, I'm defining my function which is assistant. Okay. The input would be a state. What is in a state? This particular thing. If you remember, this particular thing is a state. Okay. Now we will have our repo in the state. We will have messages in the state. If you see, we have one repo also when we created our state.py file, and we have list of all the messages here. Okay. So we have everything here right now in this assistant function. Now moving back, we said that we will have an user input. Okay. And we will pass it to LLM. Now there are some 3-4 steps which we will do in this particular thing, means moving from user input to LLM. we will do, okay, we will do this particular 4 steps. In the sense, as a user I will have a questions. Now before directly sending it to LLM, what I'll do is I will provide the repo name also to be associated from the user side. Obviously once we have the repo name, then only the LLM will go and can call the tool. That we have already done. We said that we will take the repo name here, okay, and we have the messages also. So we said that we will also pass on the repo name, okay. Now we will check if the message is coming from human, okay. We will check if the message is coming from human. If yes, we will modify the human message. In the sense, we will attach the repository and the human message into it, okay. So we will convert the human message into human message plus repository, and then we will check if the output is less than 6000 characters. If it is less than 6000 characters, obviously we will pass it to LLM. If it is greater than 6000 characters, we will trunk it down. So what I have written here right now is I'm saying that I will check if I have the repo and the last message. The most recent message is human message. If you go back, I will check if I have the repo and the last message is a human message. If yes, okay, what I'll do is I will convert the human message, okay, which is message minus one content as original questions, right? Now I will update the last message as original question, which is this one, okay, which is this one, original question plus repo. See, I have the repo name, I have the human message, so I've converted the human message as a repo plus human message. That's it, I'm doing here right now. Okay, done. Now I will call my function which is truncate if tool message, which is again to check if the characteristic length is less than 6000, this particular thing, okay. And I will also call my agent. Now what I will do is, if you see, I am basically looking for a response. In the sense, I will call my agent. I've already created my agent. If you remember, I attached my tools with the LLM, so it become an agent. So I will call my LLM with tools, okay, and I will pass this particular message, which is LLM with tools dot a invoke. In the sense, I am invoking my agent and I am passing my messages. In the sense, human message plus repo to the assistant, okay. Now, if you remember, we also said that apart from everything, since user input to tools, in order to fit to the LLM, we will also have our prompt. So if you go back in the code itself, we said that we will also pass system message along with message. System message was basically the prompt. So this particular thing, in a sense, user input to LLM has some sort of tools and the prompt. This entire connection has been done in one particular function, which is this one. Okay. Now it's just a debugging part. In the sense, I'm looking to print the LLM, if my LLM is working fine, the response of the LLM, and finally whatever the response is generated by the LLM, I will store that response, okay, in my messages. Again, what was message? If you remember, this particular thing. So if you see here, as a human, we will have this particular thing. The AI will generate an output, which LLM actually will generate an output, something like this, and we will store this. Okay, we will store this entire message plus this particular thing, as in sense who is generating it, in our message book or the state log book or the history book. Okay, this is what we have done. Now coming to the routing logic, what we have said here is in the routing logic. If you go, okay, in just this particular thing, moving back. Moving back, this was a particular thing. In the sense, we said that whenever we will pass a message to LLM will decide if the tool has to be called. If a tool has to be called, it will call the tool. If the tool has not to be called, basically it's an end process. Okay, so this condition part that we will define here right now. So what I'm doing here right now is I'm defining a function which is route assistant. Again, the input would be a state. This is state. The input would be a state, and I will look in the sense what is my most recent message. Message minus one is basically the most recent message into it. If the message says that the tool has to be called, return the tool. If the message says tool has not to be called, or there is anything apart from tool call, it's basically an end for me. Going ahead, see, if it will check what was the last message. Here is a last message which is tool call, so it will call the tool and the tool had generated in some output. It will again check what was the last message. What is the last message? It was a message which is given by the tool. It is not a tool call. So basically we are somewhere at the end part of this. Okay, so this is the routing logic. In the sense, it will check for the message. If the last message is tool call, it will call a tool. If the last message is not a tool call, it will basically end. Similar here, if it's a tool call, it will call a tool. If it's not a tool call, it's an end. Okay, interesting part in the sense we will define our nodes. We will define that we have assistant node here. We will define we have one Groq LLM node, we have one MCP tool node, and then we will connect these things in the sense whenever the user will ask a question. If you go back, okay, if I say whenever the user will ask a questions, okay, the user can also ask a question directly to the tool. The user can also ask a question directly to the prompt, but that is not the reality. So we will have to define that how the flow is going to be. Till now we have connected everything in the sense we have connected LLM with the tool, we have connected prompt with the LLM, we have connected that whenever the user input will come up, how the user input along with repo will move to the assistant. Once we have the assistant, how it will move to the LLM. Now we have to define that how the flow would be in our case. If you remember again, we discussed this particular thing in the sense when you wake up in the morning, we will have to check the status. We will decide whether you want to go for a morning walk or to have a breakfast. If we have a breakfast, obviously we will have two different options. So this entire thing, this entire nodes right now and how the flow would be is something which we will decide right now. In the sense we will be building our graph. Okay, so in order to build the graph, basically initiate the state graph, okay, which is state. We are defining nodes. Again, it's very simple. Add underscore node assistant, add underscore node tools. It's basically the name of the node, and this is the inbuilt nomenclature within the LangGraph. Okay, what I'm saying that whenever I will have some input, my start point has to be an assistant. Okay, now once I have the assistant, okay, I will decide whether, if you go back, once I have this assistant, okay, in the sense I have reached here, I will decide whether I need to do a tool call, I need to end my tool call. Okay, so every time I will decide that whenever I will reach the assistant, what has to be done. In the sense I will call my function route assistant. Route assistant has two inputs, output, sorry, either it will call a tool or it will end. So it's the same thing in the sense I will call my function route assistant. The route assistant could have two outputs, either it will call a tool or it will end. Now every time when a tool is called, it will go back to assistant. Moving back to the graph, if I show you, if you see here, okay, every time a tool has to be called, it will go back to assistant. Okay, every time. So how to write this? Basically builder underscore add edge, which says that whenever a tool is called, go back to assistant. Okay, and we will simply compile this everything. In a sense, we have defined our nodes, assistant node and tool node. We have defined the starting point. We have defined our conditional edge, which is yes or no conditions. And what I'm saying is whenever a tool is called, we will move back to assistant. So now what have we have done initially is, if you remember, we first of all created our agent, first point. Second, we defined our state and how the state flow would look like. In the sense, we will take a human message plus repo, we will trunk it down and we will feed it to LLM. Okay. Second, we defined our routing logic. Whenever we reach to a situation where the last message is a tool message, we will decide whether the tool has to be called. If yes, call a tool. If the last message is not a tool call, simply end the process. So all the functions were done. Now we need to connect all the functions. The starting point would be an assistant. Whenever you feel that you are not getting things, simply open this graph. This is the assistant. This is a starting point. Since once you call the assistant, the Groq will by default attach to it in the function itself. Once we have the Groq, we will decide, or once we have the assistant, we will decide what decision has to be taken, which is a conditional edge. Whenever we have assistant, we will have to decide whether a tool has to be called or it has to be an end. If a tool has to be called, it will always go back to assistant and simply build the graph. So our connections are done, our functions are done. Okay. This is a debugging part. I'm leaving it up to you, in the sense every time when we will run it, we will see the repo in the terminal, we will see the class name, we will see the tool call, which is the same thing here. Okay. This same thing would be printed in the terminal also. So I'm leaving it up to you to decide and to interpret what I have written. Now finally, coming to this particular thing, we have talked from this particular thing to this. Okay, now we will talk about this one. See, we said that we will have an input. Obviously, we will define our frontend in a Streamlit. We will define one function which is called ask GitHub MCP agent. Okay, user will pass the user input. The function will take the user input as an input. Okay, it will call a function. It will run basically a function. Now what you need to understand here is, again, we have our graph part. This is our graph part. It could be possible that the graph is already built. If the graph is already built, there is no point in creating something from scratch. You just need to append message into the graph. So if the graph is already built, in the sense if there is something in the cache memory, simply bypass the building graph and invoke the graph, in the sense start the function part. If the graph is not built, you need to first build the graph and then invoke the graph. Now this particular cache memory is helping you to save time in creating the graph. That's it. Okay, so moving back, we have defined our function. Okay, ask GitHub MCP agent. The input which we will provide is basically the user input. Obviously the user input, if you remember, we will have two things. In the sense, we had our GitHub repository and the user questions. So I'm passing my repo, which is a string, and the question which is also be a string. What I'm checking here right now is if underscore graph is none. Going back, if, okay, in the cache memory there is no graph, obviously build a graph. If there is a graph, or simply invoke the graph. So if there is no graph, create a graph. If obviously the graph is already there, invoke it. Okay, a.invoke, which is creating this particular graph part. The input would be message, which is a human message. The and the repo, in the sense we've already defined the input, simply defining it again here. Okay, the output coming from this particular thing in the result is stored as logs. That's it. Okay, now one thing that we didn't talked about, we connected everything. Okay, we connected everything. We said that finally we will have an input from here. We will call a function. Okay, it will create a graph. It will go to assistant node. It will go to LLM will decide if a tool has to be called, yes or no. If a tool has to be called, tool will give an output. It will go back to assistant will again pass the message to LLM. Now if the tool decides no tool has to be called, okay, that's an end. So no tool has to be called, in the sense that's an end. Now we also need to come out of this particular loop, in the sense once we have an output, okay, obviously we need to display the output to the user, this particular thing. Okay, so we need to come out of this particular loop. Again, going back, what I'm looking into this is, I will go into my logs and I will do a reverse of all the messages. Okay, now if I have the AI message as an output, if you go back, see, we had a tool call. Okay, the tool gave a message, and finally the tool message went to the AI or the LLM. The LLM converted this thing into a final output. So I'm saying that once I have the final output from the AI message, that's basically the end of my loop. That's what I'm writing here. If the final message is an AI message, okay, and message dot content is actually some sort of content, that message dot content I'm converting into my answer and passing the same thing as an output here. Okay, so this was our main.py file. Okay, in the sense we connected everything here right now. The only thing which is remaining here is how to take a user input. So we will create our file, which is final file, app.py, and we will go ahead. So just click here, okay, and create your file. That is final file app.py. I've already done it and I pasted the code. We will go through the code one by one just to explain what is the meaning of each part of the code. Now, before going ahead with the Streamlit as a front end, what you need to understand here is why Streamlit. Okay, see, Streamlit is very useful for the rapid prototyping. In the sense, right now we are working in the backend, in the sense in a terminal. Okay, obviously from the user perspective, you are not going to hand over the terminal. You will define an interface at the front end, and the user will pass on the input from the front end, and then it will go to the back end. Obviously, for this information exchange, usually done through the API call. But in order to not to make the things very complicated, and for the useful case, in a sense for the rapid prototyping, Streamlit is one of the best tool. So first of all, make sure that you have done the installation of the Streamlit. If you haven't done it, just open my channel. Okay, I've already created a playlist for the Streamlit. Okay, right from installation to your first app, do it. In the very first video, you will figure it out how to do installation. It is pretty easy. Now, once you've done the installation, moving back to our code part, what I'm doing here right now is I will go through each and every line of the code just to explain what does it means. Okay, I'm basically importing my Streamlit as an ST. Okay, and my function, which was the final function in the main.py file, which was ask GitHub MCP agent, because finally the user input will go through the ask GitHub MCP agent and we will have an output. Okay, what you can do is you can go through a bit of content around the Streamlit. If you search for the Streamlit and you open it, this is how the page looks like. Simply go on the document part. See, it is a little important for you to the document part because sometimes it makes sense to understand all these things from documentation. I'll just let you know what actually you need to study. Go into documentation part, go into the API references. This is the list of all the syntax which is somewhere used in Streamlit. In the sense, for example, if you want to write something in the front end, okay, simply write st.write hello world and you will give an output in the front end, which is hello world. Okay, say for example, if I want to show you, I'll just create a file test.py. Okay, import Streamlit as st dot write say honest pm. Okay, MCP tutorial. Save it, go into terminal, new terminal. In order to run this Streamlit file, till now we are using Python and FileName. Here what we will do is we will write a Streamlit run test.py. So as you can see here, we basically wanted to have honest PM MCP tutorial, and in the front end we have this particular thing. Now we will appreciate the benefit of using a Streamlit in the sense there is no issue with backend and front end. With only Python code, you can move all your data from backend to front end, and from even from front end you can accept the user input, pass into the backend, can do the calculation, and finally pass on the output from the backend to front end. Okay. So just go through this particular thing in a sense we have write syntax, text element, data element, chart element, whatever you want to have it. More or less you can cover everything here right now. So I'm just removing this particular thing. Okay. We would be running our original file, which is streamlit run app.py, and I'll show you the final output. So this was the final interface that we wanted to create. I'll just go through one by one through the code part and I'll explain you this entire thing. Okay. See, what I'm doing here right now is I'm using the title, which is GitHub MCP agent, and a caption. Again, there is a very straightforward GitHub MCP agent here, the title, and then is a caption here, which is this one. Paste the GitHub repo once. Okay. Now, once you do everything, obviously we will have a session state or the history part, and what the same thing what we will show here in the part of the state log. So I'm just creating an empty list of history and of repo. Okay, and obviously the state log here, and then we will keep updating it one by one as we have this entire conversation with user input, AI tool output, and everything. Okay, now what I'm doing is I'm creating a sidebar here, which is sidebar here. Okay, the header is repository. Again, just see the beauty of the Streamlit in the sense whatever you are writing right now, everything is getting converted in the front end. You don't have to worry about the back end, front end, and everything. Okay, we will have a text input within this subheader, okay, which, and we will store this input into value is basically the state.repo. If you remember, we created an empty list of the state repo. So whatever the user pass on to it, we will store it into the state repo. Okay, the placeholder is something like this: github/mcp server, and there is a help also which you can provide, which basically is a question mark. Okay, now as soon as I click on load repository, if you remember, we get this particular thing in a sense loaded. So whenever you create on this particular button which is load repository, okay, we will pass this repo, okay, into session state repo, and we will display a success message which is loaded github, or whatever the repo name that you pass on to it. Then we will create a line which is st.divider. This particular line, we will create a new button which is start new conversation. Obviously, what does a start new conversation means? That we will erase the entire history part, memory parts, and session log and everything. So what I'm saying, that whenever we will click on state new conversation, we will delete this entire thing. Okay, obviously if say the memory is getting very high, or if you want to create multiple tabs into it, this entire thing will come into play. Okay, then again we will have a divider. Okay, this particular thing, we will have our state log, whatever the session underscore state dot history I have. Okay, I will pass into state log, and I will display the output, which basically is a LangGraph, which we have already seen. Okay, now coming to the second part. So this part is done. Coming to the second part, which basically is, we will let the user ask a question. If you remember, there was a placeholder ask a question about the repo. So we loaded our GitHub repository, and then we put up the question. So same thing that we will do here is, if there is no repo, we will get a warning sign in the sense, please load a GitHub repo first. Okay, if the GitHub repo has been loaded and the user has passed the questions, we will append that entire repo plus question into our history. Okay, with role and content. Role basically would be the human message or the user, and the content would be the user questions. Now as a user, when you input in the question to the system, you also want the system to display the question that we have asked. If you remember, we said that explain the readme file of this particular repo, and when I press the enter, the system also displays me this particular question. So what I'm writing here is, whenever I will submit this entire thing, also display me the question which the user has input in the form of message user, and write that particular thing in the front end also. Okay, now we have question, we have repo, so we will call our function which is git, which is this particular function. If you remember this one, ask github mcp agent. Ask github mcp agent has two inputs, one was repo and the one was question. Obviously in this particular thing, we said that whenever we will have this entire thing, okay, this entire thing, we will have a repo, we will have user question, and we will append it to the session state or the history card. So we have repo, we have the user question, we will pass this entire thing which is a repo and question into my function which is ask github mcp agent, and we will have an output. Finally the output that we receive, I'm calling it as an answer or logs. We will write the answer in the front end. If you see, this was the answer which was generated finally after we went through this entire function. So we will display the function in the output also, and we will save this function in the log also. So I'm saying that it is an answer and log. Okay, yes, I'm appending into my session state as part of logs, and I'm also writing this particular output from GitHub MCP agent, which is an answer in the final output or in the final UX. Okay. Now, obviously, when we ask the question to the GitHub MCP agent, if you remember, this was the entire thing which we have gone through, in the sense we have the user input. Just let me clear it. Okay. We have the MCP user input in the form of a Streamlit. We pass to this particular function which is ask GitHub MCP agent. Ask GitHub MCP agent has entire thing, in the sense it will check if there is a graph, yes or no. If there is a graph, okay, there is no point in creating a new graph, and basically it will invoke the graph. If there is no graph, it will create a new graph. Okay, then it will go to the assistant node, and this entire thing is a part of this particular function. Okay, it will go to the assistant node, it will go to the Groq, The Groq will decide whether a tool has to be called or not. If a tool has to be called, the question will go to the GitHub MCP tool. The MCP tool will create an answer which will go back to the assistant node. Assistant node will again pass the output to the Groq, and this cycle will go on. If there is no tool call, basically that's an end. Since we have an end, we will extract the final message which is delivered by the AI message and writing it in the front end, okay, which is a display bubble, this particular thing. Okay, so we are displaying this everything, and whatever the conversation we have in the form of LangGraph, I'm basically writing in the session state to the history card. Okay, that's it. So we have this particular thing. We have created our first MCP tool. If you remember, this is what we talked about. We will have a user input through an Streamlit. We will have some 2-3 different things going from user input to LLM in the form of this particular thing, that we will pass the repo name. We will along with the human message, and we will check if that message is less than 6000 or not. If it is less than 6000, we will pass it directly. If it is not less than 6000, we will trunk the message to less than 6000. We will pass to the LLM. Okay, and once we have through the LLM, we will have this entire graph part. Okay, now there are some things which now you should start to apply your brain. Say for example, as a user, just think from the product manager perspective. Okay, if the user is very good, obviously he will ask the, or she will ask the question, like explain the readme file for this particular repo. Say if there are users which will simply say, okay, what is, say, explain the history of football. Now tell me, does this particular question that make sense anywhere in this GitHub MCP tool? The answer is no. And this is where your product knowledge or your ability to understand the ground requirement or the operations requirement or the people's requirement will come into play versus the people who are using it, because anyone can ask any questions. Now simply if you ask this particular question, it will go to the LLM, the flow will remain same. It will go to the LLM here. Okay, LLM will now require that there is no point in calling any tool because it doesn't make any sense. Now the question is, it's why we should allow this particular question to go to the Groq LLM. Then someone will say, okay, this is where your skills will come into play. That instead of going to directly to the LLM, okay, we will create here a new agent. This particular thing would be a new agent. I'm naming it as a, say, gatekeeper agent. Okay, what it will do is it will go through the user question first. It will try to understand what the user is asking, and does it make any relevance from the project that I am creating or from the tool that I am supposed to use. If it is making relevance, I will pass this particular message to the LLM and the flow will go on the way we have decided. If this user question is not making any sense, I will simply block it, and will say it doesn't make any sense to go ahead because this is not something I'm built for, and I will be dropping you from the call. Okay, so this understanding will come into play, and this will not come unless you create projects, unless you understand the loopholes, and then you apply your learnings that how we should do all these things to prevent excessive cost or unnecessary requirements which the user can pose. The other thing which again you can ask me, that whenever the user is asking question, it is going to LLM, the LLM is calling the tools. Okay, and it generating an output. It could even be possible that the output generated by the LLM doesn't make any sense. Obviously it can do that. So again, you can create a separate agent with what it will do is it will check the output from the LLM. Okay, it will check the output from the LLM. Okay, something like this, and will decide that this output which is generated by LM makes sense. If it makes sense, we will pass this to user input. If it doesn't make sense, we will pass this output which is generated by this particular LLM back to it to review it again and to try calling MCP tool again to get a better output. Something like this. Okay, so LLM will generate an output. Output will go to this particular agent, just calling it, say for example, grader agent, which will grade you. Grader agent. Okay, the purpose of the grader agent is to grade my principal LLM or my principal agent. So the output generated by this agent will go to greater agent. The greater agent will review it. If the output make does sense, if it makes, we will pass the output to the user. If it doesn't make any sense, we will let the LLM again retry it and generate a better output. Now the questions that will come into play: how many times we will do it? We cannot have an infinite loop. So obviously we can decide, oh, okay, we will do it 2 times, 3 times, 4 times, whatever it is, depending upon my token cost, my cost of the project, and what exactly I'm trying to achieve. So this is, so so I hope you guys have enjoyed this particular video. Okay, and I'm leaving this video with some open questions for you to understand it from product management perspective. It's not only about creating codes, it's also about understanding who is going to use it and what are the guardrails that you are supposed to create, so that people should not misuse your agents. The GitHub link for this particular thing I'll be leaving in my comment sections and even in my bio. Just go through it and let me know through my mail or through the comment section what else should I create so that you guys should enjoy it. Till then, take care, and I just see you in the next MCP tool projects.